So next you just take a tea bag, cut it open to get the tea out of its packaging, and now once you have it, just make sure everything is on the bottom so you don't spill anything out. Take the scissors and cut it on the top, but make sure you cut it straight so it's not in any angle, so when you sit it down it doesn't, you know, tip over, and don't spill it on yourself like I just did right there. But then all you have to do is kind of fold it the opposite way with the opposite lines to make kind of like a diamond, so it would be able to sit perfectly on the foil. You can see right there, and I'm gonna zoom in a little bit so you guys can see a little bit closer how it is. But just pretty simple. Just fold it so it sits like a diamond, and it will sit perfectly on the foil. Now next, you just take your lighter and just light it either from both sides or just one side, and that's pretty much it. So watch it go down. And there it goes, the flying tea bag. Just make sure when you catch it, make sure you catch it, because if you don't, the ash pieces will spread into little pieces, and then you have a little mess. But that's pretty much it, guys. Thanks you for watching. Hope you guys.
Hey everybody, it's Amanda from the St. Louis Science Center Science Off-Center team with another experiment for you to try. This one is a secret experiment, so only you and I will get to hear this one. You'll need some very simple household supplies. We are going to need a wire coat hanger and some yarn. That's pretty much it. Later on we'll need a wall, but that's all we're going to need. You're going to cut 2 pieces of yarn I cut mine about 3 feet long, and just to show you, they're not even the same length. They're pretty close, but you don't have to be real precise with this. And all we're going to do is tie the 2 strings to the 2 sides of the coat hanger. So I've got one tied there. I'm going to tie another one over here. Fingers aren't working. There they go. Okay, so now I've got this. It probably doesn't look like a science experiment, but it's actually a really cool sound experiment. You probably can hear, if I hit the coat hanger against the table, it makes a noise. But this coat hanger can make a really cool noise if we go to a wall. Once you have your strings tied to either side of your coat hanger, you're going to take the end of your string and we are going to twirl it around our pointer fingers, our index fingers, so that it looks like this. Alright, so once we have the yarn twirled around our pointer fingers, that's where our secret experiment starts. You might look kind of silly. It might attract a little attention. You're going to put your fingers so that the yarn is resting against your ears. So we're not sticking our fingers in our ears like this, but I'm resting that twirled yarn around my fingers against my ear openings. And then we've got to swing. When I swing the coat hanger and it hits the wall, it resonates, it vibrates, just like it does on the table. But the strings do something really special. The only way for you to hear it is to try it yourself, because it's a secret. So give it a try and let us know what happens and how you think it works. We'll see you at the Science Center.
It's the return of the laser.
Yes.
And the return of the very quick science experiment. This laser that Hannah has got was £3 on Amazon, and if we shine it through just a glass of water, you can see various things happening. This is just tap water, but over here is a bottle of Waitrose tonic water. Can you shine it through the tonic water? Whoa! So this is really very different. The tonic water contains a compound called quinine. It used to be possible to buy quinine, but now you can only get it with a prescription. Photons from the laser hit the molecules of quinine and get absorbed. Some short time later, they will be re-emitted in a random direction. This is what is allowing us to see the laser beam as it passes through the water. Keep increasing the angle. Oh yeah, there you go.
Ooh.
That's
Whoa!
the reflection off the surface of the water.
Really cool.
It's as though the water's surface is like a mirror. I did try this experiment with another colour of laser. We've got this Spirit level at college, which has a wavelength of 532 nanometers, but as you can see, this doesn't cause the water to fluoresce. If you want to try this experiment yourself, all you need is, obviously, a blue laser and some tonic water. A word of warning about the laser, however, it's marketed as having a power of only 1 milliwatt, but when we tested it at college, the power came out to be closer to 45 milliwatts. This means that it's not safe for us to use for class practicals at college, because anything over 5 milliwatts can cause permanent damage to your eye, so we'll only be able to use this for demonstrations. Also, the seller claims that this is a ultraviolet laser, but it can't be an ultraviolet laser because when you shine it on the wall, you can see the laser spot. When we measured the wavelength with a diffraction grating, we found the wavelength to be 400 nanometers, which is just within the visible band of the spectrum.